Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video I am going to discuss how we can execute multiple queries in Snowflake in parallel manner. Okay. So many times we get this kind of requirement where we have to execute thousands of insert queries. Okay. Now one thing you can do line by line, one by one insert queries you can execute, but that is called sequential approach. But one insert query is not taking that much compute power from Snowflake, right? So rather than using a single insert query execution in a single time, you can execute multiple insert queries parallelly, right? Because Snowflake compute warehouse is much more powerful. It can handle that much load, right? Similarly, you can consider, suppose you want to load the data from different S3 location to different Snowflake tables. Then you execute copy command, right? Now, one particular copy command that is loading the data from one S3 location to one Snowflake table is not related to how you are loading from another S3 location to another Snowflake table, right? So, what I am trying to say that parallelly you can execute multiple copy commands also, or maybe some ELT operations you are doing for processing your data. Okay, that time if suppose some transformations are not dependent, okay, then you can execute them parallelly, right? So how to do that using Snowflake Python connector, that's what I am going to discuss. Okay, and this is one of our viewers request also, who is Karan Gupta. He asked me this question basically, that is, hi, could you kindly make a video on how to run all these queries in parallel manner in Snowflake using asynchronous execution. So hope this particular video, whatever concept I am going to deliver, that will help to understand the answer of this question also. Okay, so let's see. So before starting this particular discussion, I will request you to go through this particular documentation, which I will share in this description box of this video also. Just search for async. Okay, here you will see one video on asynchronous layer over Snowflake. Okay, I have already explained how you can submit Snowflake queries asynchronously using Python connector, because that concept only we are going to use. Because synchronous execution we can do in parallel execution, right? All queries we can submit, and based on query ID later we can check whether what is the query status, whether it is still running. If it is still running, we will poll again after some seconds. If it is completed, then we will come out of the loop. Like that kind of activities we will be doing in parallel execution. So this particular video will surely help you to understand today's concept in detail. Okay, so for this discussion, first let me show you that I will try to execute one particular set of codes synchronously, and we will try to basically understand how much time it is taking, and then we will execute the same using asynchronous manner. Okay, so first step, what I am doing, drop database if exist run. I am dropping a database. Basically, I am creating a fresh database for this demo, and then here I am creating the database. I am using the database. I am creating a table called employee history, which is having employee ID, employee joining date, department salary, manager ID, and there is one more column which is T, and default value it will be taking as current timestamp. Okay. Now here what I did, I basically created a simple stored procedure. Okay. What this stored procedure is doing, if you see here, this is the stored procedure name, which is taking a string. Okay, that's why I have given varchar as data type, and this stored procedure I have written in JavaScript. So as you can see, first I am calling this call system wait 10 seconds. So for 10 seconds it will wait. It is executing that, and after that what I am doing, I am taking this particular argument input here in MySQL command to variable. I am creating the statement, and then here I am executing that, and here I am returning done. That means all I am doing using this particular stored procedure is, here to run the stored procedure we need to pass one SQL query what we want to run. First what it will do, it will wait for 10 seconds and then it will execute that particular query. Okay, so let's see what queries we want to execute. Okay, so here I will just open this particular CSV file what I created for this demo. So if you see here, these are the queries which I want to execute first synchronously, and then I will show you the asynchronous execution. So basically all these queries I will be sending in this particular stored procedure, and this stored procedure execution will happen. And what it is doing, insert into employee history. It is inserting the data in employee history table. Okay, that's all. Only in the first columns it is inserting employee ID, employee joining date, department, salary and manager ID. In the last column, which is basically timestamp, it will take the default value as current timestamp. Okay. So here to do synchronous execution, here I have written the code. Let's go through the code. So first I am importing pandas because I want to read this particular CSV file, and I will iterate row wise, and each row basically our SQL query that I will pass via our stored procedure and I will call. Okay. So here I am importing the Snowflake connector. Here I am creating the connection using user ID, password and account. So password I will be putting that later. Here I am creating the connection. Here I am creating the cursor. Here I am executing some simple SQL statement like use this warehouse, resume this warehouse if it is suspended, use this database, use this role and use this schema. Okay, what I discussed earlier also. And then here I am reading the particular CSV file, employee data.csv. As you can see here, it is basically the location is here. If you see inside C drive, then here inside user, then desktop, then talent. Okay, that same location I have given inside C drive, user, desktop, talent and the file name. Okay, and here I am iterating data frame row wise. I am taking the query column because you can see in this particular CSV, the queries are stored in query column. Okay, the column name is query. So that's what I am taking, row of query. And then another thing I am doing here, I am using dot replace. All the single quotation I am replacing with double single quotation. Okay, so actually what will happen, let me just take one insert query here. What I will do, I will come here and I will paste this insert query. So this insert query actually will be passed as string, and that one I will be passing basically inside the stored procedure, right? So I will just execute call this particular procedure, bracket open, bracket close. Okay, but see in this case the problem is this particular whole SQL query enclosed within single quote, and inside this SQL query also single quote is there. So to execute this code properly, what I have to do, I have to replace the inner single quotation with double single quotation. Okay, this is a catch point, just remember this. And now I can execute this query perfectly. Okay, it is not executing select. Where is that? Okay, I have to basically give here one semicolon. And okay, unknown this function, I will just execute that. Okay, now I can execute call. So here you can see it is taking some time. Why? Because once the query execution is started, first it is waiting for 10 seconds and then it is inserting the data, right? So it is going to take 10 seconds. Let's see. And see it is returning done. Now if I do select start from employee history, I will see one row is inserted, whatever we have passed here. Okay. Anyway, I will just create or replace this table once again so that I can show you the demo from scratch. So currently in our employee history table, nothing is there. Okay. So you can understand one thing, that all the inner single quotation I have to replace with double single quotation. That's what I am doing here. In the query, I am replacing inner single quotation with double single quotation. Okay. I am printing the query to be executed, and here I am just calling my stored procedure. That's it. Here I am executing this query, and the cursor.execute is executing this particular stored procedure. And then once the stored procedure is called, first it will wait for 10 seconds, then it will make an insert. Okay, and then after that it will go to next row, and then it will take the next insert query. Like that it will be executing. So this is a sequential manner of execution, right? So let's see how it is happening. So I will just click on run. So here if I go, here you will see it is going to take some time. Okay, so actually here it will fail because I have not given password. So here I will enter the password and run it again. Okay, so I have provided the password and let me run it now. And all these codes I will be providing in the description box or in the comment section. No need to worry. Okay, so here see call procedure is called, and now if I execute select start from employee, see currently we are getting nothing. Why? Because when the stored procedure we are calling, first we have to wait for 10 seconds, then only we are executing that insert query, right? So now see, now it is inserted. So what will happen? Now it is executing the second row. See, call demo stored procedure, insert into employee history, employee ID, employee joining date, employee salary, manager ID, department, etc. 12. Then it is executing the third row. Okay, but see, it is going very slowly, and the reason is all this stored procedure execution is taking some time, right? So I will just execute again. So see, slowly the records are getting inserted. So let's just wait for a couple of seconds. Let the program get complete and then I will continue. Okay. So here you will see the data is continuously getting ingested. So actually 7 rows got inserted, and in our this particular file we have total 8 queries to be executed, because first row is header, total 9 rows. So that means total 8 rows are there. So soon it will be completed. It is almost done up to 7. So see, process finished with exit code 0. Okay. So all the queries are inserted properly. It took a sufficient good amount of time only for execution of insert query, and intentionally I gave this particular system.wait 10 seconds to show you the impact of parallel processing. Okay, the power of parallel processing. Okay, so here if you see that, see, let's start from employee history. Just observe the last column T. Okay, so if I just sort it properly, here you will see that the first record, okay, got executed at 9:8:31. Okay, then after 10 seconds at 9:8:42, it is executing the second insert query, because every time when I am calling the stored procedure, here what is happening, first it is waiting for 10 seconds. Okay, then one insert query is getting executed. The next time, the next insert query again 10 after 10 seconds. See, the second one was at 9:8:42. Now it is at 9:8:53. That is nearly 10 seconds. Then after the next one, 9:9:04. It was at 9:8:53. It is 9:9:04. Then it is 9:9:15, 9:9:26, 9:9:38, and 9:9:49. So you can understand that all these queries are basically getting executed sequentially. And as a result, obviously, the overall execution is taking time. And not only that, there is another important point. I am executing these queries one by one, but Snowflake Compute Warehouse is sufficiently powerful enough to execute all these queries parallelly. So we are not executing the resource also properly, right? So that's why we need the requirement of parallel execution. You can understand easily that all these insert queries, if I execute parallelly, then also no problem is there. No meaning of sequential execution, because one insert query is not dependent on another insert query, right? So let's now see how we can execute code parallelly. Okay. So for that I created another table having the name employee history parallel. Okay. So here table employee history parallel is successfully created. Currently here we will be having no data. I can basically close this one, and here what I will do, I will just open another file which I created for showing the asynchronous execution demo. This file is basically having same kind of insert query. Only difference is here I have taken different table, employee history parallel. Whatever table just now I created, in that table I want to insert the data. Okay. And now let's see the code for parallel execution. Okay. So what I will do, I will delete this particular code and I will take the code what I have written for parallel execution. Okay. So this is the code I will explain. So here you can see what I did first. Import pandas as PD, import time, import Snowflake connector, and I am ignoring all the warnings. Okay. Common thing, whatever almost we did in our sequential execution, almost same thing is available here also. Then here I am taking user ID, password, account, and here I am creating the connection. Okay. And here I am creating the cursor. Then here I am executing all the 5 or 6 statements, whatever I have executed in case of sequential execution. Same kind of queries I am executing now in case of parallel execution as well. Okay. Then here I have written a particular function which I will be coming later. As of now, you just focus on this particular part first. Okay. What I did here, I basically created an empty list query ID is equal to empty list. Okay. Why? Because as you know, whenever we trigger any query execution asynchronously, we need to store the query ID of that particular execution, so that in later point of time we can poll based on that particular query ID and we can get the latest status of that query, whether it is running or success or failed, like that, right? Now what I am doing? I am reading the data. From where? Employee data async. So the same kind of data, same CSV file, just the table name is different. Okay. I am iterating row wise. I am taking individual element in row wise iteration. I am replacing inner single quotation with double single quotation as usual. I am printing the query to be executed. I am preparing the statement what I actually want to execute, that is the stored procedure which I want to execute parallelly. Okay. Only difference is earlier I was executing cursor.execute, but now I am writing cursor.execute async. Okay. That means asynchronously I am executing the query. Okay. And once I am doing asynchronous execution, obviously I need to get the query ID, and I am printing the query ID for the above execution is this. And then here I am basically appending the query ID of each execution in this particular list. Okay. So that later, using all these query IDs, we can pull what is the status, whether it is completed or not, right? So here, this is the for loop, which is basically submitting all the SQL insert queries using the stored procedure parallelly. Basically, it is executing all the stored procedure parallelly, I can say. Okay, right? And here we have captured all the query IDs. Now here, for polling that what is the status, for that here I have written a function called get status query IDs. Okay, let's see that function, and this is the function. Okay, very simple. Let me explain. Def get status cursor list. So here I am basically passing the query IDs here. Okay, because that's what you can see here, right? Here I am passing the query IDs, and that came here. So here I am printing check the status of the query list, this one. And then here I am creating an empty list status. So here status of individual query execution will be stored. Here I am doing what? Here I am creating a empty pandas data frame with these two columns, query ID and status. Okay. And then here I am writing that cursor list, that same list of query IDs for which we have to poll in a variable called ARR. And then here I am iterating. Okay. For query ID in cursor list, what I am doing here, using connection object, whatever we have created here, okay, using that connection object, I am having a method called get query status. Okay, it will give me the query status if we are passing some query ID, and you have to use dot name property to get the status, whether it is running, success, or failed, those kind of stuff. Okay, so for that particular query ID, what is the status I will be getting? That I am appending in this particular list, whatever I have created here. Okay, and also I am appending that in a data frame with the query ID and status for query ID. So suppose you have executed 5 queries parallelly using asynchronous execution. So in data frame, 5 rows will be appended. First column will be query ID, next column will be status. Okay, and then I am checking in the status, in this particular list also we have stored the status, right? So I am using dot count method to understand whether is there any single element in the list which is having the value running. That means, is there any single query which I basically executed or triggered asynchronously? Is any of their status is running? If it is true, then what I have to do? I have to again execute this get status, this same method again after certain interval, right? That is called polling. So if that is the case, I am deleting the list, I am printing the data frame, and I am also printing one or more comment is still running because it is running. Okay, then here I am making a 5-second sweep, and then again I am recursively calling the same method. Okay, so again this method will be calling, again it will be checking what is the query state. If again something is running, it will again call the same method again. Like that, it will be keep on doing until and unless all the queries whatever we have triggered asynchronously is successful or failed. Okay, that means if they are complete. Okay, else if that is not the case, that means if all the queries are completed, then we are printing all comments execution done, printing the data frame, and we are simply returning, because we no need to return something there. If required, you can return something based on your requirement. Okay, right? So I hope you understood the code. So in our previous experiment when we did synchronous execution, that time one thing we have seen that it is clear all the insert queries are basically getting executed with 10-second interval. That's why here I have given T column. Okay. Now if I am executing the queries asynchronously, what will happen? All the queries will be executing almost parallelly, and the T column will not be having that much gap. Okay. That means here, as you can see, first one is at 9:8:31, next one is at 9:8:42, almost 10-second delay or gap. That much gap will not be seen while executing the queries parallel. That's all will be our observation. Okay. So currently here, if I do select start, no data is there. I will just give the password here and then I will trigger the code. Okay. So here I have given the password and here I will run the main function. Okay. So earlier we have seen the individual query execution became very slow, but here you can see rapidly it is getting printed. Okay. Because here we are just triggering asynchronous. We are not waiting for the status. We are just calling the procedure and then here see first it is showing running. Okay, that means all the queries are running. The next time one query, two query are success but others are running. So that's why it is printing one or more command is still running. And then again after 5 seconds when it is polling, all the queries are successful. Okay, now let's see if I do select start from employee history parallel. Here you will see, let me just sort it. Okay, so just observe the gap. First one was executed at 9:28, then 0.697. Next one at 9:20, 09723. Next one at 9:20, 09783. Okay, that means up to millisecond also it is same. Next one is at same time 9:20, 09. Okay, just little bit millisecond delay. Okay, up to second part it is matching. But earlier we have seen for all the queries it was having 10-second delay, right? So that one is overcome, and from this time column hope you are getting that all the queries are basically triggered parallel. Okay, clear? Like here last query you see at 9:20:10, that is 9 PM 20 minutes 10 seconds it got triggered. Second one also same. In the millisecond level differences. Okay, so that means you can understand all these code procedures, whatever we have started execution here, like here executing the query this procedure, then executing the query this procedure, executing the query this procedure. So all these basically started execution almost same time. And the reason is very simple. We are not waiting for the code procedures to be getting complete or successful or failed, whatever. Okay, just we are triggering, we are tracking the query ID for future polling and we are coming on. Okay, so I hope with this particular discussion you are clear about asynchronous execution in Snowflake using Python connector, and I hope this particular requirement is also clear, Karan, if you are watching this video. And all these codes I will be providing in the description box or in the comment section. You can play with that, just twist it or change it based on your business requirement and just play with it and modify it and have fun. Okay, this is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you.